Hello, everyone, and thank you for joining us for our UCLA Alumni panel about the future of robotics. My name is Joshua Hooks, and I'm going to be leading us on this journey. We have a great panel for you today, including myself and Min. The two of us are currently UCLA graduate students that work in the Robotics and Mechanisms Laboratory. We're always trying to push the boundaries of legged robotics. Joining us is Roy Lim, a alumni of UCLA and currently an entrepreneur whose international companies have been changing the face of robotics. We will be discussing UCLA's involvement in the international community, particularly in how they pertain to the world of robotics. We will also be talking about the direction of robotics as a whole because, well, robots are awesome, and whose minds are better to pick than two robotic PhD students and an entrepreneur? If you have any questions throughout this, please feel free to post your questions via the chat function, and we'll try and answer them as we go along. To get started, we'll let the other two panelists introduce themselves, and we'll get going from there. So, Roy, why don't you start us off? Tell us a little bit about yourself.
All right. I was in UCLA from 2005 to 2007, and I was studying computer science there and focusing in AI. And then after that, I went to work as an IT consultant in LA for 2 years, and then went to Chicago for 3 years of work, and then I came back to Hong Kong. But after I came back to Hong Kong, I really missed California. So I opened a robotic system integration company back in Fremont, which is in Silicon Valley. And that company actually worked out really well because there are a lot of good ideas in Silicon Valley, but they are only ideas and they cannot become real products. So we used our expertise in robotics and how to make manufacturing lines and help these people make their ideas into real products. And from 2015 to 2017, our revenue grew by 1,600%. So that's about 17 times.
Wow, that's awesome. All right, Min, how about you tell us a little bit about yourself, and then we'll get back to Roy and his companies.
All right, cool. Hello, everyone. My name is Minsung Lee, and I was born in South Korea. However, I spent a majority of my life, elementary school, middle school, and high school, all in China. I was based in Shenzhen, so it's like a city right off of Hong Kong. And in 2008, I came to UCLA to do my bachelor's in mechanical engineering. And before I graduated in 2014, I also attended the Korean military. And then since 2014, I've been in Dr. Hong's Robotics and Mechanisms Lab working on legged robots.
Awesome. So our panelists, we kind of have the current UCLA graduate students going through robotics, and we have our expert that has graduated from UCLA. So today we're just going to kind of talk about robotics and how UCLA has affected our careers and how they're interacting with robots. So I think where we should probably get started is, Roy, do you want to tell us a little bit more about your company, and how robotics are involved, and maybe something that stems from UCLA?
Sure. So as I said, we are helping people to create their ideas and make it into reality. So some of our products are actually very close to daily life. So for example, we helped a company called Zoom Pizza, and they have an idea that creates a pizza with robots. So we help them make the robotics and the gestures for putting on the ketchup, the cheese, and then finally we put 50 ovens on the truck and put these uncooked pizza onto the truck and take the GPS signals when it's 6 minutes before the arrival of the pizza. We put the uncooked pizza into the ovens, and by the time it arrives the customers, it's very crispy and very hot.
Oh wow! So you actually put the ovens into the delivery cars, and so when someone takes it out, there's no, oh, my pizza might be cold. It is right out of the oven, huh?
Yes, no more sake pizza.
Oh, that's awesome. So what part of that is what part of that? So it sounds like the whole thing is automated. Are there any people involved, or is this completely a robotic company?
Yes, there are still people involved because in the kitchen, they still have a lot of choices. Like you put peppers on it, put mushrooms on it, and that part is actually done by a chef. But we only have one chef serving the entire San Francisco.
Oh, interesting. So there's one. Wait, you said there's one chef that is helping. So basically, I mean, and this is kind of, we can get deeper into this because I feel like this is where robotics is at right now, which is if you have kind of a repeated task where there's, you can just do it over and over. So I assume like spreading sauce or something like that, you can automate. But then when you have custom, some people want half sausage, half olive, or this and that, then you need a little bit more. And that's where you still have the human element coming in.
Yes, very true. Especially when the orders are very complicated. They want it spicy, but a kind of spicy and a little spicy. That's very difficult for us to put into a robot because it's very humane. It has to be human.
Interesting. Okay. And I believe you have another company also in Hong Kong.
Yes, actually, it's our family business. We are the largest Mitsubishi distributor in China.
Oh wow.
And that it's mainly the robots, the PLCs, the motors, controllers, CNCs, and these. It's a very big business. We have presence in Shanghai, Shenzhen, Beijing, uh, Wuhan, Chongqing, and our headquarters is in Hong Kong, which is where I was born.
That's awesome. So where do you spend your time? Are you in Hong Kong or San Francisco, or do you split time between them?
Always flying.
Always flying. Okay. All right. So I guess kind of to get some background, how did you get involved in robotics? Why was robotics a thing for you? And then also I want to know, where did you start from? But let's start with you, Roy.
Okay. So I was studying computer science, and I had these opportunities to work with the professors in computer vision because I was focusing in AI. And I had the search algorithm, I had the natural language processing, and I was thinking, where can I apply all these knowledge into one unit, in one product? And then I found out that my father has actually got all these platforms for making robotics. So I didn't want to really program for a screen or a game or anything, just software. So I came back and then I took all these products and the technical team and then asked them to just build this robotic platform and help people in real life, not from the screen.
That's awesome. Man, how did you get into robotics?
I don't know. I guess like you guys recall the movie I, Robot?
Yeah.
Yeah. So I guess when I first watched that, I just had like this like really naive thought when I was really young, like I want to make something like that, like Sunny. And then it just like kind of drifted away because I was doing like a lot of different things, building websites, like doing these like white hat hacking stuff also. So a lot of different random things. And then I think it was like around 2013 or so was when I saw Boston Dynamics Wildcat. So yeah, I think that was like one of their first really fast, quadruped, like a robot with 4 legs running around. And that was like when I was like, man, I'd like to do that for a job. And then it's just been like, I kind of wanted to do it, but I guess back then UCLA, when I was an undergrad in UCLA, there wasn't as big of an infrastructure around, giving opportunities to students, that wanted to tinker with robotics. I think that has changed a lot now. So there's like a lot of student clubs here where, you know, undergrads, if they wanted to get involved, they can get involved. But for me, you know, so after watching those videos, I decided to, you know, more actively look for some clubs that might be doing something similar. And then I started playing around in this like underwater robotics club here.
Yeah.
And then after that was when I met Dr. Hong, and he was setting up a lab in UCLA. And then, yeah, that's how it all started, like seriously started.
Yeah, yeah. As you can see, Min is sitting in our lab, RoMeLa, and you can see that there's quite a few robots behind him. Trust me, it's a fun place to play around if you like robots. But personally, for me, it sounded like both of you guys started on the software side of things and then realized that the software could be used on the physical side. For me, ever since I was a little kid, I like taking things apart and putting them back together. Unfortunately for my mother, I was better at the taking things apart part rather than the putting back together, but I got better at it. I got better. But as I continued on, it became very clear to me that I should be an engineer. They are always taking things apart and putting them together. And it wasn't until college that I took a robotics class and I saw what a mechanical thing, when it comes to life, what robotics can do to a mechanical thing, that you can make, these metal parts, and software and wires and everything works together and it moves like an animal, like what Min was saying, watching the Boston Dynamics. And I just fell in love with it. I absolutely loved going from a concept that's just completely cold and very mechanical to something that comes to life. And it's really cool, especially when you demo it for like a little kid and you just see their eyes light up. I don't know. It'll never get old for me starting up a new robot and bringing it, to life. That's awesome. It sounds like we all have quite a few similar passions.
I think
sorry. Let's get to the next one, which is I guess let's continue with the passion. So what is your guys' favorite robots? I guess your favorite projects that you guys have worked on? Min, how about you?
Yeah, so I guess, I'll start, I guess. So, I don't know, I'd have to say really, like competitions. I like a lot of competitions. So when I'm working on a project, if it's something for a competition, I really like it. Definitely, I'd have to say in 2015, the DARPA Robotics Challenge and the RoboCup, using like the humanoid you see back there, Thor, was probably like my favorite project for sure, because it's like, so the competition part really propels people to push technology forward, because you're now not doing things just inside this lab environment where everything is controlled, but now there's all these uncertainties that these competition moderators are throwing at you. So yeah, I'd have to say, like, right now, Thor RD is definitely still one of my favorite robots, because competed in 2 competitions with it, and I think we'll be mentioning about our next one later, right? Yeah. But yeah, definitely right now it's this one for sure.
How about you, Roy? What's your favorite, school project, career project, what have you?
So I was talking about Zoom Pizza, which is a really nice,
awesome,
groundbreaking pizza machine.
That does sound awesome.
That is awesome, but I feel better when I can actually help people. Like, we are working on a robot right now for reactivating the movement of stroke patients. And it's actually a neuroscience technology where, when you have a stroke, actually not every part of your body is damaged. Only your brain cells are damaged. So with our robots and our data, we can detect when the patients want to move, and then we will trigger the movement of their muscles. We just use motors to move their hands and stuff to let the brain knows that the hand is still there. So the brain will actually allocate other neurons to move the hand again. And we have tested with hospitals, and we actually achieved 90% movement back to the patient after they got a stroke.
That's
So
awesome.
I feel really good
Yeah.
when I'm doing things like this.
Yeah, I mean, I think that's one of the biggest things is, what's really cool about robotics is, it's awesome to get these things to work, but what's really cool is they actually can make a difference. And the project that Min was talking about, it competed in the DARPA Robotics Challenge, which was the challenge to try and push robotic technology so that it can help out in disaster relief situations. And that's what's so, I don't know, it's what keeps driving me, and it sounds like keeps driving you, is that you can actually see that this will help people, that this is going to make a difference. And that, I don't know, to me, that's what, A, it's fun problems to solve, and B, you get to contribute, which is just awesome. So how far along in the project are you guys? Is it in testing? Is it, out there? Are you allowed to talk about it?
Which one? The medical?
The medical one.
It's actually being mass produced right now.
Oh, wow. That's awesome. So
you'll probably see it in March next year.
Oh, that's really cool. That is really cool.
That is cool.
Actually, we have our first question from someone watching. M. Lee wants to know, how does UCLA and USA compare to what other countries are doing, exploring, accomplishing in robotics? I think as the international part of it, I think I'll let you two take this one. So what is to sum it up, what is UCLA and USC versus the international community? How do the robotics compare and those sorts of things?
Well, let me start first. UCLA is itself very international in my opinions. So when I was in UCLA, I met a lot of people that are from other countries. So I'm able to work with people from Singapore, Korea, and India, everywhere, and they have very good resources from the government as in creating these new technologies. And in USA, it's mostly very private. Like you get your own money from investors, but we get a lot of money from investors because in Silicon Valley, there are tons of money ready for robots. So I think the freedom of environment in USA is helping us to create very innovative robots, while in, let's say, Hong Kong, we get a lot of resources too, but they want you to be working on specific directions because it's their money.
Interesting. Yeah, I don't know, Min. I know you're still in grad school, but you came from Seoul. What do you think about this?
I think like I share like a similar sentiment to Roy in the aspect that a lot of the, I guess, like the non-US countries, they tend to have like very specific goals on where they want to apply these robotic technologies. So when you're working on a project, we have like a couple international ones, and it, like the goal is very specific as opposed to some of the stuff that we do, like the grants from US agencies, it's kind of open-ended. But at the same time, it's like we're at 2018, nearly 2019, and the world is just so connected, and that I think from like a government level, it might be a little bit focused outside, but I think from like a graduate student's perspective, a lot of the people are doing very similar things, and all the information is really just openly available if you're not a corporation. Right. So in the academia, yeah, it's all openly available. So I think it's like kind of hard to differentiate what the US is doing as opposed to like what some of the places in Europe they're doing, like Korea, Japan, China, what they're doing. It's kind of difficult to distinguish like who's like, just because they're working in the US, they're doing something different. Yeah. But at least in the academia.
Yeah, I mean, just from being at UCLA and observing, I mean, I would think, UCLA just seems to me to always be trying to be involved in the international community. Since I've been at UCLA, I've gone to Seoul, I think 3 times, Hong Kong once, We just went to Spain, and so we're always trying to be active in the international community. And honestly, everyone knows who UCLA is, so it makes it pretty easy to communicate. And as far as robotics go, at least in my opinion, I don't know. It always seemed to me that UCLA was at the forefront for, especially on the sides of like AI and it's the birthplace of the internet. But there wasn't a huge what we'd call physical hardware for a while. But then UCLA about 6 years ago decided to change that and brought in, our professor, Dr. Hong, Veronica Santos, Jacob Rosen, these awesome professors. And so I'd say that UCLA really is, the question about accomplishments in robotics, there really are teams now at UCLA that are really competing at a world-class level. So I don't know, it's pretty cool. There's actually another question. This one's directly from Min. Did your time in the military influence any of your work in robotics?
I'd say so. I guess like where I was stationed at wasn't very like a technological place, but it was really like at the forefront of like it was pretty much at a heated place between South Korea and North Korea, and I guess not specifically to robotics, but in terms of technology itself. From there, I did realize that a lot of the technology that we should be developing should be really for the greater good of the humanity, keeping people safe, keeping people that need help, provide them with help, with like the necessary help. That type of stuff I did get to reflect on a lot for the 2 years because, just looking over the border and looking into North Korea, like there's a lot of places where we could develop robotic technology and help these countries that are relatively, not as advanced as some of the more advanced countries in the world. But I think there's, our lab works on super advanced robotic technologies.
Right.
Some of these countries around the world don't need something as advanced. They might need just something simple to, like transfer water from one place to another for that specific area. So those type of things I did get to reflect on a lot. Yeah.
That's cool. All right. I want to dive into a question that actually I've been interested in, Roy, when I found out what your companies were and your background. Everyone's interested right now in AI and machine learning. It's a huge hot topic. However, what I want to know is how have you found a way to incorporate this into your companies? How have you found a way to make it successful? AI has been successful in limited, in some situations, if you have, for instance, image processing and stuff like that. But one thing with physical robots, it's very hard to get machine learning to work on physical robots. So how have you incorporated that into your companies, and how did you get it to work, or what are you using it for?
Yeah. It's actually very difficult to find a platform to apply AI.
Yeah.
It's not always a chessboard where you can play a chess piece once per turn. So we have to define our own problem, especially in the industrial area. For us, we have our own machine, which is a polishing machine, which we have patented and we have used it extensively in the polishing market. What we do is we help these Swiss watches to, it used to be all human polishing the watches. And these humans are putting their hands really close to the 2000 RPM wheels and just doing it all manually. Now we are using our machines with our pressure control to solve all these problems, and no more accidents, no more bad lungs because of the dust. Now, when we are polishing these watches, we have to achieve a certain result. And so far in the past 2,000 years, it could be polishing of weapons, it could be polishing a watch. Whoever is calling out the result is just based on their visual or
there was no metric. Yeah.
It's by eyes. Now, it's very difficult to find a very straightforward criteria for saying whether this is shiny or whether this is okay. Now, we have done, so every time now we have polished a watch, we will add a picture of it. It's a really high resolution picture, it's 20 megapixels, and it's really closed up. And then we will take that picture, put it into a database, and ask the QC guy, do you think this is good or not? Now, if he says it's good or not, we will put it into the database. And after millions and millions of watches, we'll use AI to actually learn from the patterns and see whether there are specific patterns, and we'll know. Now we don't need that QC guy because he could be very ill or he is very tired and he can see some patterns. And this is a very good example of using AI because
definitely.
it actually does what human cannot do.
Yeah. So, I mean, and that is actually exactly kind of where I think we're at with robotics, which is to explain to anyone that doesn't, I think most people know what AI is, or on some level, but to explain a little bit why AI is hard, what Roy was talking about, to integrate into a platform with AI. Notice how he said you needed 1 million, 100,000. You need a large volume of data, basically. And with walking robots like Min and I do, you do one data set and the robot falls over, it breaks, you have to fix it, and then you get a second data set half an hour later, and you have to spend 6 months to get 100 data sets. And right now with machine learning algorithms and AI, it's hard to do anything with that sort of data set. So that's why I was so curious how Roy has been integrating, and that's a great application. That's actually really cool that you guys did that. So yeah, I don't know. That's awesome. Actually, Roy, I am curious. So I'm curious from the perspective, Min and I, we're still in grad school. We're dreamers. We are working, we're working on legged robotics, but I want to know from someone who has had commercial success in robotics. So what we focus on is legged robotics, and, everyone, wants it, but they're like, oh, that's not commercially viable. But in the last 5 years, or even actually in the last 2 years, I don't know if you're familiar with Boston Dynamics mini spot. There's even a Shenzhen one, like a Go animal out of Zurich. These platforms seem like they're really close to being commercially viable. I'm just curious, do you think that the world, it's always been dominated by automation. Do you think the world is almost going to get, robots that are walking among humans, or do you think we're a ways away, from at least being a commercially viable object?
Well, it depends on what is almost. 5-10 years, I don't think so, because we are still developing all these prototypes and then combining it with AIs, and in 5 to 10 years, it will still be a very good assistant for human. I would think in 10 to 15 years, maybe it will become the replacement for some of the most dangerous jobs or things that we cannot do now. Like we can't breathe in space, so we will send drones walking in space and then finding things. Now, after 15 years, I'm not sure, because it could be developed into a very autonomous technology, and at that time we will have to have our own measures to protect ourselves. Because if we put too much into the technology, let's say a Tesla car, how do you know it won't hit people all by itself? So we have to be cautious.
Yeah, totally agree. I don't know. I mean, I think it's an exciting time. Definitely, I think Min and I really like what we do. But yeah, I mean, I don't know. When we get the robot to walk across the lab, we're pretty excited. It's like, yes, that was great. And I mean, getting it to walk across the lab is getting to be more boring, but still walking in itself is a challenge. And then, and then after that doing a task. You can't just have it walk. Now you have to have it do a task. And so I think I agree with your timeline. But to the two of you, and I guess I'll send this to Min, what do you think we need to bring it from out of the laboratories and actually have it be in the world? How do we have robots walk, not just walking, but also like a robot arm to be a chef and stuff like that? Where do I get my robot butler? What technologies do we need to get there?
Yeah, I actually wanted to ask that exact question to Roy. So yeah, because I think like Josh and I are still in the lab, we have everything perfect and still like we're fiddling around in like a very controlled environment. But I guess like the stuff that you've deployed in the real world outside of labs right now, I guess, what do you think, like what triggers were available for you to actually deploy it now as opposed to like 10 years ago?
Yeah, actually, let's pertain this to your pizza company. Yeah. What is it? How did you know what could be automated, and where did you go, no, we shouldn't automate that, we should still have a human that? What do we need to, take out the human and completely automate that task?
At this point, this is a very good question, because every factories that we help automate, they have the same questions. Which part should I keep to human, and which part should I automate? And usually we take the most dangerous, most dull, and whatever it's the human doesn't want to do, to automate first. And then we keep the human to collaborate with all these machines. Nowadays we have something called a work cell, where automated machines are not put into one straight line anymore. It's put into a circle, and the human is actually in between. So now all these very complicated or customized works are done by the human in the middle. And then once he's done with that, he'll put it back into the robot, and the robot will do the rest. Now, I'm very sad to say, the linked robotics will definitely be very popular in the future because of climate change. I think very soon we are not going to be able to walk out to the beach and enjoy the air outside. So maybe in 30 years, only robotics, linked robotics are available for us to go to a trip or go outside. Very sad, but I think it's a very big market for you guys.
I think it's the first time I've heard that, actually.
Yeah, that is the first time I've heard it. I mean, it makes sense. Well, as well, it's the 3Ds, the dirty, dangerous, and dull. As you get more dirty and more dangerous, then there's more opportunities to take over dangerous and dirty jobs. So that makes sense. But yes. Okay, so I think we're coming to a close, but first I have one more question, because I think this is important to both of you. As a student who is an international student here and someone who's gone on, if you could give one piece of advice to a international student who is at UCLA or thinking about coming to UCLA, what would it be? What piece of knowledge do you want to give to this person that you wish you had when you were there?
Me? I'll start first.
Yeah.
I really think you guys, or whoever is coming to UCLA or studying there, should not just focus on the subject. Go out and join. I was in the EGSA, the Engineering Graduate Student Association, and we had a lot of social events, and we met people. And make sure you print a business card. We did not have that back then, and then I lost a lot of contacts, and I regret it.
That's good. That is a very good piece of advice. I can already tell you that was a very good piece of advice. Min, how about you?
Yeah, I kind of agree with Roy on this, because when I was accepted to various schools, I was accepted to schools that ranked higher according to certain, like college ranking websites. But a big reason why I chose UCLA was because it's in Los Angeles, And why I say that is, even if I was in mechanical engineering, doesn't matter what type of major you're in, because you're in a city that's so vibrant, so many things going on, pretty much anything that you can find somewhere else in the world, you'll find it in LA also.
Yeah,
So
there's
there's
always someone coming by the lab to either film or learn about it. Yeah, I mean, it's
so much stuff going on here.
right there. It's actually kind of fun to be in robotics.
Yeah. Like, so at UCLA, you're not going to like a certain, school, but you're really just coming into like this city, this Los Angeles. And there's so many other opportunities that you could, enjoy and experience. And it's a great school also. And there's a lot of international students also. So you're not going to feel like you've just dropped into like the middle of nowhere. So I think it's very welcoming community. The city is super cool, and the weather is fantastic also. So there's like not a lot of reasons for going against UCLA actually.
Awesome. All right. One thing I wanted to add in, if for everyone that's watching out there, Min and I are actually. Min hinted at it. We're trying to develop a new humanoid robotics platform to compete at RoboCup 2020, but we're actually doing a campaign to try and fund this. So it's actually kind of crazy. We're trying to do a crowd-funded robot for the first time. So if you're interested in it, if you could go and you want to check it out, do spark.ucla.edu/RoMeLa. I believe it should be in the comments. So that would be great. Check it out. If you like looking at cool robots, go there. But to everyone watching, thank you for joining us and participating in the discussion. If you missed a portion of the conversation or want to share it with others, you can find the recording on our UCLA Alumni YouTube channel. And once again, thank you to our Blue, Gold, and Life members for making conversations at an event like this possible. Have a wonderful day and go Bruins.